Hey guys, Mr. T here, just another video. This one is on geometrical facts. So geometric reasoning is a branch of maths where we use a bunch of known geometrical facts to find unknowns and using two-column proofs, which is the formal way of posing an argument in maths. So this is going to be a bunch of terminology here, not really any working out, but you have to use this language to do it properly at this level of maths. So a polygon, you've probably heard that word before. Some geometric reasoning involves polygons, so it's important to define exactly what a polygon is. So a polygon is any closed two-dimensional shape with straight line edges that don't cross over each other. So we've got some examples here. Which of the following are polygons? So you can check off whether they're polygons by seeing if they meet the criteria. Closed, 2D, straight edges, don't cross. So this is a rectangle, they're straight lines, so it is a polygon. This is a circle or maybe an oval. Now obviously it's a basic shape and we can do maths with it, but unfortunately it doesn't have any straight line edges, so not a polygon. And this figure here, it almost looks, it's a triangle essentially. Well, not really, it's almost a triangle, because it's got a gap there. So it's not closed, which means it's not a polygon. So that's just a couple of examples. The only other thing that you could, I should probably show for a polygon or not polygon is if you had a shape like this and crossed over itself, that's not going to be a polygon, okay? Unless in the question you divide it into two triangles. So moving on, we've got some geometrical facts or geometrical definitions that you need to know. The following are geometrical facts used in geometric reasoning. So the first idea is an angle. Whenever you've got two lines, so this line AB and this line CB, when they meet, they form an angle between them. Now the angle is named based on the labels and the lines forming the angle and where the angle occurs. So where the angle occurs must be in the middle of the name. So that name, this angle could be written as angle A, B, C. Why? Because B is where the angle occurs and it's in the middle of that name. But you could also name the angle the other way around. You could name it angle CBA. That would be perfectly fine too. It's up to you to decide which way you want it. The important part is you call it an angle with the angle symbol there, and you put the B where the angle occurs in the middle of the name. Next is the idea of a revolution. So a revolution is a complete turn which equals 360 degrees. So that's going to be a 360 degree turn there. A straight angle is another idea. If I've got a straight line there, it's actually a 90 degree angle straight up and then another 90 degree to the left here, in this case. So 90 plus 90, 180 degrees. So a straight line, or half a revolution, is 180 degrees. A right angle, a quarter of a revolution, is a right angle or 90 degrees. So that nice square corner there is going to be 90 degrees. Some angle terms here. A reflex angle is an angle that goes beyond a straight line. So this is a line here. A straight line would be there, but this is bent down. So you've gone further in the angle than a straight line. That's called a reflex angle. But it's still below a revolution, so it hasn't gone all the way around, more than around. It has to be between 180 and 360, so it would be this sort of area here. An obtuse angle is any angle more than 90 degrees but less than 100, so 90 degrees would be here. This angle has gone up to 90 degrees and a bit further, but hasn't gone past the straight line, so it's obtuse. And any angle that's less than a 90 degree angle, so 90 degrees is there, any angle less than that is called an acute angle. Another term that you need to be aware of is the term complementary angle. If two angles add up to form a right angle, they are complementary. So in this case, A plus B will equal 90 degrees, therefore complementary, because they form a right angle. Supplementary angles If two angles add up to form a straight line, or 180 degrees, they are supplementary. So in this case, I'll just use the one color. These two angles, A and B, they're going to add up to 180 degrees. So they are supplementary. Some line terminology. We're talking about lines here. A line is infinite. Okay? It's an infinite straight line going through 2 points. So when you say line, you're actually talking about something that goes on forever and goes through the 2 points along that line. You would write a line as just A, B in curved brackets. Now if you're talking about a line segment, which is only the line between A and B and not any further, so not infinite, you're going to write AB in square brackets. And it's part of the line going through the points AB, but only the part that lies between the 2 points. So only this section. You're ignoring everything that goes beyond B and beyond A. Another term is the idea of concurrency or concurrent. Lines are concurrent if 3 or more of them pass through the same point. So all meeting in the one place. Collinear is another term. Lines are collinear. No, that's incorrect. Points are collinear. Points are collinear if they lie in a straight line. Next, lines are parallel. So parallel lines are marked by the same arrowhead. If they've got the same arrowhead, that means they're parallel. And what does parallel mean? That means they neither get closer together or further apart. And lastly, lines are perpendicular if they intersect at a right angle, and you can mark a right angle with a little square at the angle that's meant to be 90 degrees. So that's a little bit of line terminology and angle terminology that you're going to have to use. Hopefully that helps you out. See you in the next video.